Well, I'd like to thank everyone for coming out this evening. We have a very special guest tonight talking about, which I think is a very big topic, right, wouldn't you say? Recently named as one of the top 20 big data influencers by Forbes magazine. Rich is an avid writer, publisher, and technology pundit focused on high-performance computing. He acquired InsideHPC.com in 2010 and has since expanded to include Inside Big Data. Rich has over 25 years of HPC experience at Cray Research, SGI, and Sun Microsystems. Rich is known to many in the industry as the guy in the red hat. When he's not working, Rich keeps busy writing fiction, cartoons, and parody films. You can check out his latest works at The Three McGee of Katrina, 7 Meals from Chaos, Jigsaw, Falling into Place, and Bardo. Rich lives and works in Portland, Oregon, and he's here to tell you how you can make money on big data.
Well, yeah.
Some of the trends and...
We'll do exactly that. Thank you so much. All right, guys. Well, let me just say how excited I am to be here. And I'm going to tell a lot of stories. I'm a writer. I'm a storyteller. I'm not a statistician. So the notion of being an expert on anything is kind of uncomfortable for me. But I have been writing about big data for the past 2.5 years. And prior to that, my focus was all high-performance computing. And there's a lot of overlap there. So let's start by talking about what big data is not, because people take it literally. Okay? Big and data has to be large. Well, big is relative. What is big today in science, in big data analytics, might be very small tomorrow. And so we have our sumo wrestler fellow here, and his little compatriot here, he might be a bigger man someday. And this is very important because when I'm talking about big data tonight, for tonight's purposes, big data equals high performance data analysis. And actually IDC came up with this term over much deliberation, working with the HPC guys and the big data analytics folks to come up with something they could both be comfortable with. Because the folks that do big data don't consider what they do high performance computing. If you say supercomputer and HPC, we don't do that. That's not what we do. When they think of that, they think of supercomputing simulations, nuclear weapons, weather forecasting. No, they're solving business intelligence problems, right? So we'll get more into that later. So tonight, what I want to tell you about is that big data is about two things. And the first one is it's about money. Otherwise, you know, why would you care to listen to even the rest of my talk? If this isn't about money in the end, and the opportunity to make more money and save more money with lower risks, then it isn't really worth our time. Now, how big is that opportunity? Well, I've seen figures as big as saying the big data market will be $50 billion by 2017. It depends what you include. You know, storage devices, all this, right, middleware. Okay, but either way, what's driving that? And I think you guys in the telco space, and the folks in this room, this chart's from IDC, but I borrowed it from my friends at SGI. This is where IT budgets are going. And chances are that number is not going to go much steeper, given the business climate. This is where data is going, and this gap represents your opportunity, folks. Whether you provide cloud services or ways that they can deliver services, you can sell storage into that space, but there it is, right? That's the money. Now, what's the second thing? And this is where I'm going to tell you about an insight I had, and you can feel free to disagree with me, but it comes with a story. When I redesigned my site, we hired a data scientist, because for the first 2 years of Inside Big Data, it was just me writing about big data analytics as someone from the outside, trying to learn it, trying to get my arms around it. Just like watching Star Wars over and over, what's this story really about? And I didn't think it was about the bits and the bytes. I didn't think it was about predicting the future and everything else you might be reading about what is big data about. And when Daniel Gutierrez, my new data scientist, came on, one of the first stories he wrote was a tech tip about something called Bayesian statistics, and I didn't know anything about it. And I was like, oh my God, I just read this post. It's my site, and I don't understand my own publication anymore. So I need to get educated. I went in, and I learned something. I was reading all about all these algorithms and all this stuff, and this Bayes guy that really invented the big data science was way back in the 15th century. And it said the philosophy of decision theory, the Bayesian inference, is closely related to discussions of subjective probability. Well, I didn't know what that really, couldn't really get my arms around that, but this is what got the aha. Bayesian probability provides a rational method for updating beliefs. Now, if you think about what is the most powerful force in the universe, besides maybe nuclear force, it's beliefs. And this drives everything, especially in our society. And I came to this conclusion that this is really what big data is about. Big data is about degrees of belief. Now, if you're scratching your head about that and said, no, it can't be about that, but think about Wall Street. If you think a stock is going to go up or down, what is that worth in terms of dollars? This happened today. I copied this tweet from Twitter. These 12 words just cost Facebook $18 billion in value. Just this one sentence that follows. It says, we did see a decrease in daily users, specifically among younger teens. Now, what does that mean? That means that teenagers don't want to be on the same social network as their parents. Should that surprise anybody? Right? So Facebook is facing a real crisis here, and that's what people read into that. Their degrees of belief shifted to the point that they lost $18 billion on paper. So, being that Facebook is a company that's very heavily rooted in big data, and it's done a lot with MapReduce and things, I just found this fascinating. So where are we headed tonight? Tonight, we took a poll at the beginning, and about a third to half of you, I asked if you believed the big data hype, and you raised your hands. Well, tonight, by the end of my talk, I'm hoping that we can get a much greater percentage of you increasing your belief, your degrees of belief about big data. So that's where I want to take you, down the golden path. And how are we going to get there? Well, I want to tell you how big data brought me to you guys, because the Forbes thing is an interesting story. I'm going to tell you some case studies about companies that are using big data and getting real value, money value out of it, in concrete examples that we can all kind of relate to. I'm going to talk about high-performance computing, because that's my roots, and the contrast with big data, and where they overlap. And then finally, what's coming. So, before we get there, beware the big data naysayers. There are folks, and some of them come from the old data warehouse space or wherever, but they've got an agenda. In this case, I think this guy, I think he's a good writer, but I think he's looking for clicks. He wants people to read his story. So if you can say something that's contrarian to what other people are saying, that big data is this great new wave coming, you'll get readers. And I see a lot of stories about this. I'm always patrolling. There's at least 3 stories a week like this, that big data is a bunch of hype. So I went to a data scientist, a friend of mine named Rob Farber, and I said, well, okay, I think he's got a legitimate question here. If big data is so powerful, how come it can't predict the economy? Because, economists have been messing with numbers for years. This is what they do. And yet, we don't seem to know day to day if the economy is going to go up or down, or if Greenspan wears a red tie, suddenly that affects the stock market, right? So here's what he said. He said, well, wait. You got to break it down just like a scientist would look at this problem. The economic system is nonlinear. Even a small stimulus, therefore, can create a completely unexpected result. And it's a complex dynamical system where you don't have clear knowledge of the initial conditions or the conditions of the stimulus. You just got vagaries there. So big data can help you find averages, find needles in a haystack, help you identify accurate models, and hopefully that will help you determine where the market might be going. Now, how did big data get me here? And this was last year in February. I was looking through stories, and I saw the headline on some tweet, oh, Forbes top 20 big data influencers. And I went to read it because I thought my friend Henry Newman would be there. He's an expert on I/O. And he is the guy you go to if you want to move data around quickly. And I went through the list, and lo and behold, there was my name at number 12. Now, there's reasons for this. I'm pretty prolific as a writer, and I'll show you some of the statistics, but I have something like 1,300 videos out there that are about HPC and lectures and things like that. But I've been writing about HPC as a blogger since about 2003, 2004, whenever blogs started back there. And but this is what this guy used for this article was these 3 metrics of reach, resonance, and relevance. Now, to show you how insightful big data is, big data brought you to me. Out of those 20 people they named, I am the only one that instead of a picture, a photo, they have a cartoon character. So that tells you what big data, how insightful it was. So let's talk about some case studies. And this one also illustrates the difference between where we don't worry so much about the largeness of the data set. In Japan, sumo wrestling is a very, very popular sport, of course. And they did a study where they used very disparate sections of data, and they found evidence of fraud. And it was very startling. What they found is that if this guy, all these guys, to stay in the league as professional, they have to have a certain percentage of winning, or they get booted. Okay, they're no longer going to be in the club. They can no longer. That is their lifeblood. This is how they earn their living. They will be kicked out of the sport if their winning percentage. What they found is that in matches that didn't really matter, that were like in these tournaments, matches that didn't matter to anything as far as the end result of the contest, that if this guy needed a win to stay as a professional, it didn't matter if he was up against the equivalent of the champion of the world, that guy would throw the fight and let him win. And they wouldn't make it obvious. So this entire sport came into question, and this had a lot of cultural significance. I mean, because it's all surrounded with ceremony and honor. And these guys were throwing fights, and they got busted. Now, this particular data set, as I said, is not that big. It would fit on your hard drive. But it is definitely a case study for big data because they use different types, mostly unstructured data, to put these relationships together and find the fraud. Now, the next one is probably closer to more of the hearts in the room, I would think. Sports, fantasy football. I just did a podcast with this fellow that runs this site called predictionmachine.com. And he started at ESPN as a wizard statistician and doing their graphics, but he started coming up with algorithms that would predict the outcome of games. Now, if you go to this site, they will have the entire NFL season totally plotted out as to who's going to win. And so far, they're doing quite well. They are much better than a coin flip. Now, we asked him in the podcast, do you affect the Vegas spread? And he says, well, they won't really say, but we've seen evidence of that. Now, what is this guy doing? After every play at an NFL game, he runs the entire season through his simulation model again after that play and sees how it affected the outcome. Now, what are there? 6 games going on at any given time on a Sunday? Those also get fed in as well. He runs that simulation 50,000 times on a cloud server before the next play happens. That's the computational power has enabled him to do that and increase his accuracy. Now, his algorithms are very sophisticated, and basically what the guy is selling isn't what you might think. It's not for people who just want to go bet and beat Vegas. It's for these fantasy football guys. They want to have the best players with the best. They want to know who to pick. And you get a subscription to this, and you've got you can kick your friends' butts because this is really forward-looking and use of big data. So fascinating. If you think about all the variables in a football game, somebody gets hurt or whatever, all that gets figured in, and they run it through the simulation again, and out comes what they think who's going to win. So, by the way, they say the Broncos are going to win the Super Bowl. They do other sports as well if you're into hockey and basketball, by the way, so I highly recommend it. The next case study I want to tell you about is mortgage fraud. There's a company called LexisNexis, and you might be familiar with them from, well, they sponsor NPR, right? But they have legal databases that lawyers use to find precedent and stuff like this, right? But they also have a risk analysis group, and they developed a technology that, think of it as Hadoop-ish, but it was developed 10 years before Hadoop. They've since open sourced it. It's called HPCC, and it's very, very powerful. In this case study, LexisNexis has a database of all of us. And they have 270 million Americans in it, and it's very good at discerning who you are. If you have a common name like John Smith, they know which John Smith you are. They have multi-layered algorithms and ways to filter. Now, this is something that's very important in mortgage fraud because there are organized crime groups based in Russia that are going around buying houses and selling them to each other. And through LexisNexis' database, they're able to track these guys and see what their relationships are. And basically what they'll do is they'll buy a house or a commercial property, and they will sell it within days, and they will continue to strip the equity out of it through each transaction until some guy at the bottom just stops paying. Okay, he's the fall guy. And he won't be able to play the game for 3 or 4 years till the cycle starts again, the fall guy. But the other ones will just be in these cycles and be flipping these properties for the purpose of fraud. And LexisNexis estimates that the savings they could have to just Bank of America is in the hundreds of millions of dollars a year in avoided fraud. Now, they work with the FBI. In the old days, if you look at a loan application, this is very hard. It's hard to tell who owned your house before you if it's not recorded on a deed, especially if there's been a lot of flips and mortgage securities. You have no idea what's transpired, and neither does your lending agent. So that's what this particular case study, and I asked the guy, what do you sell this for? Do you sell it by, get a percentage of, or do you sell it by minutes of access? And he said, well, our product guys are really working on that. But the potential for money savings is enormous. And by the way, I saw a big data talk earlier this year by Bank of America. What do you think the number one indicator is that someone's going to stop paying on a loan? Any guesses? The number one indicator, that if the bank sees it, they're never going to see another dime. If the man or the woman pays a bail bondsman, that is the last that bank will ever see a dime. Now, that doesn't exist in one database. They had to use big data to make that correlation. And you think about how, well, I guess that really makes sense, but no one had made that leap before, that's what they need to go watch. And because that person is just, they're done. They're done paying. Now, our next use case example comes from our friends at Teradata. When you think about money and big data, think about telco subscribers, the people that, what do we pay every month? $60, $100, right? And now, losing subscribers or groups of subscribers is real money. That's money you were counting on, right? That could kill you, especially if there's this thing called churn. And if you happen to lose someone through, let's say they got some bad customer service, something like that, if they're influential, their friends in their immediate group are 6 times more likely to churn as well. So if I'm an influential guy and say I have 1,000 followers that think I know everything there is to know about cell phones, and I say, hey, I just saved $20 a month by switching from AT&T. Think about what that could mean to a telco company. Millions and millions of dollars. Because these folks, with the Teradata, they're able to spot these relationships, find their, who they're connected with, how influential they are, through multi-layered screening. And they can do these queries, oddly enough, you don't need to be a data scientist to do it, and that's the power of what they're up to. It's a simple SQL query, right? So very powerful in terms of, when we talk about money, this is a great example, I think. Okay, now let's talk about government, because government is one of the biggest potential customers for big data. And they're pretty good at some things. And as we learned with Edward Snowden, maybe they're not so good at other things. David Bader is a friend of mine. He's a professor at Georgia Tech. And he's working with DARPA on a project called ATOMS. But what it is they are trying to predict when an intelligence agent, somebody with security clearance, is going to go bad before they go bad. And what it does is their algorithms will look at their emails and look through psychological profiles and past things like that. And they will see, we need to come talk to this guy. He seems a little troubled. Or his credit is a little out of whack these days. But the thing is that this is Big Brother, spying on Big Brother. These guys sign up for it, right? If you have clearance, you basically, okay, yes, you can go use this program on me. If you think about the potential damage of an Edward Snowden, or worse yet, somebody that's going to go postal, right? Very powerful technology, and kind of scary as well. All right, so HPC and big data, and where's the book? Men are from Mars, women are from Venus. Whatever, is that the one? Yeah. Okay. But there's some overlap here that I want to describe to you guys. Let's talk about what's changed. We touched on this earlier, but this huge explosion of unstructured data has made a big, it's been a force that has brought us what all this big data hype is because of that. I'm convinced of it. There was an article this week by Matt Assay. Great article. There's a URL there. But why do the traditional relational database vendors, your Oracles, SAPs, are just not getting any traction in this big data space? It's because it's unstructured data. It doesn't fit well in what they do. In fact, it's tremendously inefficient. And Hadoop is brilliant in that they made it open source, right? And I have a publication also called Inside Startups. And I've interviewed over 90, 100 companies that are doing big data startups. And not one is using Oracle or SAP. They're all using open source technologies. And if you think these are the companies of tomorrow, if I was Oracle, I'd be scared. So what does that mean? That means in big data, there is no eminent domain. This isn't necessarily going to be the people who have owned it before. The IBMs, the Control Datas, the big companies. This is a frontier, guys. And I think you folks, hopefully today, when you go back home and start thinking about, there's such opportunity here for what you guys do. So let's talk about with HPC what's changed. And here the differences are so dramatic. Okay, I started at Cray Research in Chippewa Falls, Wisconsin. That's why I talk like this. In 1986. Now, at the time the machine there was the Cray XMP4. 4-processor vector machine, a big monolithic mainframe type computer invented by Seymour Cray. Vector processors, custom processors, by CMOS, fast memory, expensive. Anywhere, I would $15 million for the 4-processor, to 30, depending on how much disk you bought and everything else. Okay. Now that was an 800 megaflop machine, which is 10 to the 6th. Fastest machine in the world by far. In fact, something like 1,000 times faster than anything you could buy at the time. Today, The fastest machine in the world is Tianhe 2. It was built in China. It uses Intel processors and Intel Xeon Phi coprocessors. This is a massive machine. I went and saw its predecessor last year, which was actually based on GPUs, Tianhe 1. And 3,120,000 cores, x86 cores, when you count the ones in the Phi, which are, I think there's 60 in a Xeon. Yeah. This performance number of 33.86 petaflops, that's 10 to the 15th floating point operations per second. Look at that expanse of performance difference. Now, Seymour's machine was very compact for what it did, okay? In fact, he was a genius at packaging. That's what Seymour was best at, is getting the stuff in a small space. Tianhe 2 is a vast machine. It's not the size of a soccer field, but it's probably close to the size of a basketball court. And it's extremely dense. I mean, they have to use all kinds of exotic liquid cooling to get all that heat out of there. Yeah. How many megawatts is it? 17 megawatts. So Andy here told me that, or no, the other guy told me that this facility is about 15 megawatts, right? For all these cloud servers, that one supercomputer is consuming that all by itself. So what is the HPC frontier? And I hope you can see this, but this is statistics from, this is what the national labs want. And they put these numbers out to the vendors, like in this case, Panasys. And I taped this at a conference in Switzerland. But these guys are all from the various vendors talking about how do we get to these numbers. Next year, well, the fastest, put it this way, the fastest file system in the world right now, production, is at NCSA Blue Waters, terabyte per second. These guys by next year want to be at 6.67 terabytes a second. That's 6.5 times increase. I don't know if they're going to get there because Blue Waters is a monument to intelligent I/O with help from Xyratex, and that's a big Cray machine. Okay. File system bandwidth, 100 terabytes a second. Okay, so, but 2018, there's this thing you've probably heard of called exascale. And what that is 10 to the 18th flops. And for a lot of science breakthroughs, they think that's the performance we need to really start doing some groundbreaking stuff. Or at least the people that'll pay the bills that make things that go boom want that really badly. But it will have, such a machine could have really huge impact on science, because if somebody told me this once, that what's not going to be exciting is, an exascale, but when average scientists all over the world can do petascale, that's when it becomes interesting, right? Right now in the world, there's only about 30, 35 machines that can do petascale. But by this time frame, that will be a commonplace type of computation capability. So, in big data, what are the companies to watch? I talked to all of them on both sides, coming where I'm. This is the most recent one was a company called Continuity, and I just thought this was brilliant. They've got a big data app server, and basically, programming with Hadoop is hard. I mean, you're really getting down in the weeds, and most programmers just don't know how to do that, nor should they need to. Continuity lets Java programmers do this, okay? I think they're well worth a look. They just had a 2.0 release of the reactor. LexisNexis I mentioned, and they have an open source component. They're working a lot with government, but I think they have huge potential outside of that. And then, all right, all these companies here, there's a lot of middleware, people that try to make Hadoop less painful. It's very difficult to set up a Hadoop cluster and maintain it. So Hortonworks, Cloudera, Zetaset, Mongo, all these guys. Teradata is more of an old school coming into that. But as we saw with that example with the telco and the churn, really doing some fascinating stuff. Now on the HPC side, IBM has made over $13 billion in the last 6 or 7 years, $13 billion in acquisitions around big data. They saw this coming before anybody, I think, and they put their money behind it. Of course, they know how to do the computation. They bought a company called Platform Computing that was mostly the HPC space. They're one to watch there. I think platform is something that could have a pervasive effect on what IBM does as a company. So HP, yeah, they want to be in there. They spent $9 billion on a company that, I don't know if that panned out so well, but they are going to be players. They are the #1 HPC vendor right now in terms of market share at about 31, 32%, closely followed by IBM. Don't count them out. Dell's gone private. We're not sure of their plans, but we know that storage and big data is a big component of what will be coming. And they've got some really smart people that came over from Sun that are going to help them with that. And I wish them well. Mellanox is a company I work with a lot. They make InfiniBand, and their silicon also does Ethernet. So the same hardware on the fly can switch and do Ethernet protocols depending on what your computation setup needs to be. Very interesting. They're doing a lot with photonics as well. Intel doesn't really have a storage play, but you know what? They bought a company called WhamCloud that was the primary developer of Lustre. Lustre is the fastest way to move data as far as a file system. That's what Blue Waters uses. So if you're going to really move lots of data around, you need Lustre. Intel's getting very much into that, and I wouldn't be surprised if they started becoming a storage vendor. They also have designs on exascale, of course. Okay, so NVIDIA, lo and behold, the co-processors that made those Tianhe machines so fast can also be used for big data. And the good news is that there's probably 1 billion GPUs in the world because they come in almost every decent laptop these days. So they're easily accessible as far as a development platform. So I think we'll see good things from NVIDIA, and they're getting in bed with ARM for future supercomputing architectures that could be very exciting in terms of energy efficiency. And finally, Cray. You know, Cray's always been known as the big supercomputer company. They make the big ones for the government. But they're making a big data play with something called their MTA architecture. It's called the Eureka machine, and it's got huge memory. And so when they do a graph analysis, they can fit these gigantic things in memory and access it very quickly. It's more of the mainframe kind of play. We'll see how that pans out. But they also have a terrific storage story because you think about it, who knows more about moving data around than Cray? They just have to. When you got a machine that can compute all that, you got to know your I/O. So that makes sense. And then finally with startups, like I said, I've talked to so many, I think it was fair to mention just certain ones tonight. So as we come to the end of the talk here, I want to share some important insights on big data from Intersect 360 Research, Addison Snell. When you think of it, big data tends to be synonymous with Hadoop. Don't get caught in that trap because it's not. There's much broader. It's just a subset. People are spending money on it now. He estimates 25% of their IT budgets are being spent on big data in some way. And performance matters. When we say high performance data analysis, if you can't compute it in a reasonable amount of time, the data's stale. It's not worth doing. And we think that the HPC market has a lot to offer the big data folks in terms of technologies. We've been doing clustering for a lot longer. Things like security that Hadoop is terrible at, they've got that licked in HPC and things like that. So that remains to be seen. So in summary, big data is about two things: money, opportunity, making money, and through risk analysis, keeping that money in your pocket or your corporate bank account where it belongs. And big data is about degrees of belief. And I got that that used to be the poster on Mulder's wall on the X-Files, right? So call to action. Any good presentation? I couldn't really think. So just check us out at InsideBigData.com. The data scientist, Daniel, that I was working for, is amazing, great writer. He makes things understandable. And I'm always chipping away at stories, and there are things that I find. So that's really coming along. And then I want to recommend you buy this book. If this stuff's intriguing you, get this book by these guys, Victor and Kenneth Cookier. Fascinating. It's got more case studies in there. I didn't want to borrow too many from them tonight, but it's a book you won't be able to put down. So, last call to action. As a writer, I wrote a story about big data. And I kind of took this theme of degrees of belief. And the tagline is, a scientist seeks to use big data to prove the existence of God. Okay. Now, like all sci-fi things like this, don't worry, it doesn't end well. But I'm going to show you a movie trailer tonight. And at the end, there'll be a link on, you can download this story and check it out for yourself. So I have to thank iTunes for that, and they have the London Symphony Orchestra, and you can make your own trailers with iMovie, and if you haven't done it with your home movies, it is so fun, and it's really easy. So thanks for that. So, okay, so let's take the poll again. How did I do? Did I move anyone's degrees of belief about big data? Did anyone? No? Didn't? Oh, come on. Maybe a little bit? No, I didn't say I moved it positive. Did I move it? More hands. Okay. Okay, fair enough. I want to thank you guys for having me tonight. This has been great fun. And we hope to see you at Inside Big Data. Thank you very much.